Good morning friends. Welcome back to Pannika's tutorials. In this video, I want to discuss how to write a C program to swap two numbers without using a temporary variable. Those who know the C programming language, they would have thinking, sir, this we already know, so why should we watch? But in this video, I will discuss in three variations. We can write a C program to swap two numbers using three techniques. I will discuss all these three techniques. So I request everyone to watch the complete video for better understanding. First, let me discuss what is the swapping of two numbers. Let's take that A value is 20, B value is 10. If I want to swap them, I need to exchange the values. So if this is my input, the output should be A value should display it as 10 and B value should be displayed it as 20. So this is what we will call it as swapping, and we should not take any third variable. That is what we are saying, without using a temporary variable. If you did not understand what is swapping, let me discuss with a simple example. Now let you see that in my left hand there is a red marker, in my right hand there is a black marker. Now what I should do is that if this is the looking, it should be like this. In the right hand the red marker should come, in the left hand the black marker should come. So this is what we will call it as swapping. Now let me write the C program for it. Now if you look at, we will have hash include stdio.h, okay, and I will write void main. Then I will take two integers a and b, and I will ask the user printf enter the a value, a and b values. Let me write like this, enter the a and b values. Now scanf %d ampersand a comma ampersand b. Now those who are beginners, they don't know what is this printf function and what is the scanf function. This printf function is used to display the output, whereas scanf is useful for us to read the input from the user. These two functions are the inbuilt functions which will be used there in the library called stdio.h, which is a header file. So in this header file you will have the inbuilt functions such as printf and scanf. This one is to display the output and the scanf function is used to read the input from the user. Okay. Now you can ask me, what is this ampersand a? Don't think that it is a bitwise AND. This is an ampersand a. Whatever the value you are reading, that value you want to store it in the address location of a. When I discussed about the data type, I told you that if you are writing int a, then in the memory location you will have the, suppose if it is a 16-bit compiler, 2 bytes of memory will be allocated. 2 bytes of memory means you will have the address also. So that address will be represented using the ampersand variable name. So here the variable name is a, so that's why I'm writing ampersand a. So whatever the input you are reading from the user, that value you want to store it in the address location of a, similarly in the address location of b. Now I have got the a value and b value. Now I need to swap those two values without using any temporary variable. Now let me write that logic. I will write the logic first, then I will explain you. A is equal to a plus b, b is equal to a minus b, a is equal to a minus b. So this one we are performing using addition and subtraction. Using addition and subtraction, we are swapping the two numbers without using the temporary variable. Okay, then what I will write a statement called printf %d a comma b. Okay, then I will write a statement called get ch. You can write any information here. You can write that after swapping the a value is equal to %d, b is equal to %d, then you can write a comma b. Why I have written simply is that to make you understand in a better way. Now what is this printf function? This printf function is to display the output on the console. Now what values you want to display? A value and B value. They are integers, so that's why I'm using the format specifier called %d. Now you can ask me, sir, when you are writing the scanf, you are writing percentage ampersand a, address location of a, but when you are printing using the printf, you are writing a only. Here we are storing the value in the address location of a, but here we are displaying the value of a. That is the difference between the ampersand a and a. Now let me discuss this logic. Let's take that a value is 20, B value is 10. Okay. Now what is this one will happen? A is equal to A plus B. Okay. So first A plus B will be performed, and whatever the result you are getting, that value will be stored in the variable A. Now A value is 20, B value is 10. That is what we have taken. Okay. So 20 plus 10 is 30. Now A is consists of value as 30, because 20 plus 10, 30, that value need to be stored in the variable A. So previously 20 is there, I have updated to 30. Now the next expression is B is equal to A minus B. Now tell me what is the updated value of A? Updated value of A is 30. What is the B value? 10. So tell me 30 minus 10 is what? 20. So B will get the value as 20. Okay. Are you able to understand it or not? Now let me execute the third step. A is equal to A minus B. What is the A value? 30. What is the B value? 20. So 30 minus 20 is 10. So that value will be assigned to variable A. So when we are taking the input, we have taken A value as 20 and B value as 10. Now if you look at the final result of A and B, A is having the value called 10 and B is having the value of 20. So we have swapped the values of A and B without using any third variable or temporary variable, using the operators such as addition and subtraction. If you display the A value and B value, you will get the value as 10 and 20. So I hope you have understood the C program to swap the two numbers without using the temporary variable. So this is about the addition and subtraction. Now the same program I will write with the help of multiplication and division. Then I will discuss using the bitwise exclusive OR operator also. Now in place of these three steps, if I write these three steps, let me discuss. Okay, the entire program will be same. Now what I will do, I will write A is equal to A into B, B is equal to A by B. Okay, A is equal to A by B. Now using the multiplication and division, we are performing the swapping of two numbers. Now look at this one. If the A value is initially 20, B value is 10, now I want to get the output as A value 10 and B value 20. Let's see whether it is happening or not. Now A is equal to A into B. What is the A value and what is the B value? A value is 20 and B value is 10. So you are getting 20 into 10, 200. That 200 will be stored in the variable called A. Now you are writing B is equal to A by B. Now remember one thing, this is the binary division. Whenever you are performing the binary division, you will get the quotient and remainder. This operator will display the quotient for you, whereas the modulus will display the value as the remainder. Okay, are you able to understand? Now look at the A value. What is the A value? A value is 200 and B value is 10. So 200 by 10, you will get the quotient as 20 and remainder is 0. But however, the division operator will display the value which is quotient. So 20 you will get, the 20 will be stored in the variable called B. Now look at the next statement. A is equal to A by B. So A value is 200, B value is 20. So you will get the 10. The 10 will be assigned to the variable A. So you have taken A value 20, B value 10. Now you got the A value as 10 and B value at 20. So we are done with the swapping. If you display it, you will get the 10 and 20. So this is about addition and subtraction. This is using the multiplication and division. Now let me discuss using the bitwise exclusive OR. A is equal to A exclusive OR B. B is equal to A exclusive OR B. A is equal to A exclusive OR B. Okay, I hope you are understanding. Now to make you understand this concept, let me take the A value as 7 and B value as 4. Okay, now after swapping, I should get the A value as 4 and B value as 7. Now look at A value is 7. So A is equal to A exclusive OR B. Okay, this is bitwise exclusive OR. Now A is in the decimal number. This will be converted into a binary number. Let's take that I am representing it as 011. I am storing it in a 4-bit register. This is the binary equivalent of 7. Now 4 is there, which is 0100. This is 4 in the 4-bit register. Now what is the exclusive OR? If both the inputs are same, means 1 exclusive OR 1, you will get the value 0. 0 exclusive OR 0, you will get the value as 0. 1 exclusive OR 0, you will get 1. 0 exclusive OR 1, you will get 1. So if both the inputs are different, you will get the output as 1. If both the inputs are same, you will get the value as 0. Is it clear? In the operators concept, I have discussed about the bitwise exclusive OR clearly. If you have any doubt, please go and watch that video. Okay. Now with this truth table, let me perform the bitwise exclusive OR. You have 1 exclusive OR 0, you will get 1, 1, 0, 0. Is it clear? You are getting the A value as 2 right now. Okay, because A is equal to A exclusive OR B, which is 011. So if you convert this binary number to decimal number, you will get the value 3. Sorry for it. Okay, 1, 1 is equal to 3. Okay, are you able to understand it or not? Now what you need to perform? B is equal to A exclusive OR B. Now what is the A value is consists of 3, so which is 0011. Are you understanding it or not? What is the B value? B value is 4, which is 0100. Again, if you perform the exclusive OR, you will get 1 exclusive OR 0, you will get 1. 1 exclusive OR 0 is 1. 0 exclusive OR 1 is 1. This is 0. So you are getting the B value as 7. B is equal to A exclusive OR B. See, A is updated to 3 and B value is still 4. I have performed 3 exclusive OR 4. I got the 7. Now A is 3, B is 7. Okay. Now what is the next step? A is equal to A exclusive OR B you need to perform. What is the A value? A value is 3, which is 0011. B value is 7, so 0111. If I perform the exclusive OR, 1 exclusive OR 1 is 0, 1 exclusive OR 1 is 0, 0 exclusive OR 1 is 1, this is 0. So you are getting 0100, which is nothing but 4. Okay, so if you look at here, initially we have taken the A value as 7 and B value as 4. After performing the swapping, we got the A value as 4 and B value as 7. So this is about swapping of two numbers without using a temporary variable in 3 variations. This is about addition and subtraction, multiplication and division, and exclusive OR. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.